everyone. In our previous video, we have seen how to draw graphs of y equal to sin x and y equal to cos x. In this session, we will be trying some more trigonometric functions in which the first is graph of y equal to tan x. Now, when you read tan x, what comes to your mind? It is nothing but sin x upon cos x. Now, sine and cosine you have seen in unit circle case. Their sine theta and cos theta, they were related to theta, and we have tried that how to draw graph of y equal to sin x and y equal to cos x using unit circle. But nowhere on the unit circle we have mentioned anything about tan x. But then sin x and cos x can come for our help. So if at all I have to get tan x, then I will have to do this mental exercise. I'm just trying to show you that some angle x I take, then corresponding sin x and cos x values I try to actually measure and write in the columns of x, sin x and cos x. Now if at all I have to get tan x, then to get tan x for each value of x, sin x upon cos x I will have to find out, and that I will write below tan x. So in this way I can have four columns, and actually to draw the graph of y equal to tan x, only first column and fourth column are of our use or our help. So understand one thing, that values of sin x and cos x you will have to write. From where you will write? Either by measuring, by giving different values to angle theta, and then actually measure how much is sin theta and how much is cos theta on unit circle. This is one way, or go by graphs of y equal to sin x and y equal to cos x. Choice is yours. Actually, while drawing graph of y equal to tan x, sin x and cos x columns are not to be shown. Only x and tan x is sufficient. But that entire exercise of writing some values in column of x and writing values of tan x in column of tan x and then actually drawing the graph, that part I am just skipping, and then I directly come to that how to draw the graph of y equal to tan x. Obviously we will need two axes, x axis, y axis, which I am naming. X is kept for the independent variable. Our independent variable here is angle theta, which we had used in our previous sessions. Naming was different. Don't get perturbed because of that. And y stands for, that vertical axis stands for the dependent variable. Here dependent variable is tan x. So values of tan x would be measured vertically and angles would be measured horizontally. So some important positions I am trying to show here, that minus 3 pi by 2, minus pi by 2, pi by 2, pi and 3 pi by 2. These are important angles in case of tan x. I have shown some perpendicular lines also. I mean lines parallel to y-axis also have shown. Why I have shown, within no time you will understand why I must have drawn those lines also. Now when actually I try to plot the points like x comma tan x and then join them by smooth curve, then kind of curves what you are going to get would be something like this. So basically these are branches of tan x. When you see angles between 0 and pi by 2, graph is going up here, but then this graph does not meet that line which I have shown as the dotted one. And that dotted line I have shown, that line is parallel to y-axis and passes through this pi by 2, x equal to pi by 2. Now line does not meet the curve I am saying. Similarly, that happens at x equal to 3 pi by 2 or x equal to minus 3 pi by 2 also, minus pi by 2 also. Curve is not meeting the line. So in mathematics, we call this as the line which meets the curve at infinity is called asymptote. So all these dotted lines are nothing but the asymptotes. Okay, this I'm just giving you from my side. Immediately that is not required, just keep in your mind. Now certain observations I want to make from here. Now what I observe first thing is that graph, when you see, those branches are similar in nature. So basically y equal to tan x repeats its behavior. So since it repeats its behavior, so this is called a periodic function. So the moment you say periodic function, as I said before also, that periodic function means you should get that habit only of writing there itself what is the fundamental period. So fundamental period of tan function is pi. Why do I say that fundamental period of tan function is pi? That what you see, say in 0 to pi, there is one branch which goes up and there is another branch which comes down. Now this kind of behavior you will see in the previous interval also of length pi. So since function repeats its behavior, so we say that it is a periodic function, and after interval length pi, it is repeating its behavior, and there is no other interval length which is smaller than pi. So we would be calling pi as the fundamental period. Now some of you may say that this is the fundamental period, but then what about 2 pi? 2 pi is also a period, but not fundamental. Fundamental one is the one which is the smallest one. Okay. Now, what can be the next observation? Now, tangent function is, or tan function is increasing function in 0 to pi by 2. What I see here is that graph goes up. Now, as values of x increase, values of y also increase. So, tan x is an increasing function. Now, why only in 0 to pi by 2? Graph is increasing in many other intervals also. So just try finding more intervals where tan function is increasing. Now, this is about graph of y equal to tan x. Now, what comes to your mind? What may be the next? Since now tan x is known to me, try cot x also. Now, as I said before, that table what I talked about, like x, sin x and cos x column you make, and one column of tan x. Similarly, you can make one column of cot x also, in which values of 1 upon tan x can be stored, and then just look at column of x and column of cot x to draw graph of y equal to cot x. Now here also we will be taking two axes like x and y. Horizontal one I am naming as x, which is kept for independent variable, that is nothing but our angles, and the vertical one I am naming which as y. Now that would be used for values of cot x. Again, some important positions or angles I would show here on the graph. After showing this, we will use now angles I have mentioned. Now we will use values of cot x, plot them, and then what you see is nothing but branches like we have seen in case of tan x. Only thing is behavior is little different from tan x, and that was expected as cot x is 1 upon tan x. So wherever tan function increases, their cot function would decrease because of that reciprocal what we are taking. Okay. Now here also some lines, dotted ones what I have shown, they are going to be asymptote. Some important observations we try to make here. Like cot function is also a periodic function like tan function. Now how much is the period? That repeated behavior what we are expecting, that is, for example, from minus pi to 0, one branch I am seeing here, and similar behavior I observe between 0 and pi, that similar branches appearing here also. That means after interval length pi, function repeats its behavior. So cot function is periodic and its fundamental period is nothing but pi. Now 2 pi, 3 pi are also going to be periods, but not the fundamental one. The fundamental one is the one which is the smallest. Okay. So this is about periodicity of cot function. Also, we can see that cot function is a decreasing function in 0 to pi by 2. Again, only one small interval 0 to pi by 2 I have taken. We have seen tan function was increasing. As I said, cot function is expected to be opposite in nature. So here we observe that cot function is decreasing in 0 to pi by 2. This is about y equal to cot x. That small interval only 0 to pi by 2 I had taken to see that cot x is decreasing. You can actually check for yourself that which all other intervals are there where cot function is decreasing. Now you should get habit of trying these things on your own. For that you will have to draw the graphs on your own. Please understand that how angles are changing, what is the nature of the graph, then only you will be able to write statements on your own, as I am asking you to find the intervals where cot function is decreasing. Now next is y equal to cosec x. The moment you see cosec x, you know it is 1 upon sin x. So make a column of angle x, then sin x, and make third column as cosec x, where you will be writing values as 1 upon sin x. And then for each x, since you have with you value of cosec x, so plot the points x comma cosec x. Now x axis, the horizontal one is kept for the angle, vertical one is kept for the dependent variable which is y here, and there you will be actually measuring values of cosec x. Now plot the important positions like minus 2 pi, minus 3 pi by 2, minus pi by 2, pi by 2, pi 3 pi by 2, 2 pi, etc. I'm just showing some part. Now, also, I try to draw some dotted lines for making you realize that now there are going to be some asymptotes. Asymptote means line which does not meet the curve at all, or rather, if at all it meets, it would meet at infinity. Now, behavior of the cosec function is something like this, what I'm showing here in the graph. Now, looking at the graph, I can see that this is also a periodic function. Now, cosec function is a periodic function. Why do I say so? Because I can see that function is repeating its behavior. Now, the moment I say periodic function, it should be my habit to write there itself what is the fundamental period of cosec x. Between minus 2 pi and minus pi, there is one branch which is above x-axis. Between minus pi and 0, there is another branch which is below x-axis. So, pi cannot be fundamental period because one part is above x-axis, other part is below x-axis. So if I take this entire interval, that is from minus 2 pi to origin, if I take this, then one branch above and one branch below x-axis. Same thing happens in the next interval of interval length 2 pi, that one branch is above and one branch is below. Not only that, order is also similar. First is the one which is above x-axis and the next one is which is below x-axis. In the next interval, similar thing happens. The one which is above x-axis is first, and the second one is the below x-axis one. So understand that graph is showing repeated behavior, and after interval length 2 pi, function repeats its behavior, means fundamental period is 2 pi. Now also try to see if function is decreasing or increasing anywhere. I observe that between minus pi by 2 and pi by 2, function is decreasing. Like when you move from say minus pi by 2 to 0, graph is going down. So it is decreasing here, and between 0 and pi by 2, graph is again coming down. So this is also decreasing. So in minus pi by 2 to pi by 2, I can say that graph is decreasing. Understand one thing, that at x equal to 0, sin x was 0. So x equal to 0 will not work for cosec x. So in the domain of cosec x, x equal to 0 is not there only. So don't worry for such points where function is not defined. Wherever function is not defined, those points would be eliminated from the domain itself. Now we tried to see how cosec x works, but we haven't yet tried sec x. Now may I leave that exercise to you? You try to draw the graph of y equal to sec x, and for that you will need values of cos x. Like what I mentioned in case of cosec x, you will be needing the values of sin x. Same way, in case of sec x, you will be requiring values of cos x. Now also, once you draw graph of sec x, now study both the graphs of y equal to cosec x and y equal to sec x, and check which all intervals are there where sec x or cosec x are increasing or decreasing. These exercises I'm leaving to you, and please go through them. For that you will have to draw the graphs, and when I say draw the graph, please just don't read or don't see the graphs. Actually pick up paper, pencil, draw the graph and understand which all points are the bothering points, which all points are the favorable points, etc. And nature of the graph, nature of the function, you should be able to remember. I'm not saying by heart it. Once you do this exercise frequently, these graphs, these shapes would be there in your mind. We did today, we tried to draw graphs of y equal to tan x, y equal to cot x, y equal to cosec x, and y equal to sec x I have left to you. Please complete that exercise, and in next lecture again I will be getting something new for you. Till then, stay tuned. Thank you.